Problem 27, write a possible equation for the given graph. This is a polynomial graph, so you should be familiar with the graphs of polynomials. And a polynomial can be written in two ways. You can write them in standard form, and that's very nice and compact, but not geometrically very helpful. Alternatively, you can write them in factored form. And that's guaranteed thanks to the fundamental theorem of algebra. So we're going to shoot for this. This one is more compact, not very geometric. This one is quite nice to interpret geometrically. And you can see the zeros, the x-intercepts of the graph. And that's what we're going to do. So we're going to look at the x-intercepts. We have 1 at -2, and the graph looks like that. There. We have 1 at -1, and the graph nearby looks like that. We have 1 at 1, and the graph looks like that. So that's going to give us some factors. And these factors will be of the form x plus 2 and x plus 1. But this is a shifted version of parabola or degree 4 monomial. So I'm going to go with the simplest choice. I'm going to put a square. Remember, when the power is even, the graphs of the monomials, they look like that, the toolkit functions. And when the power is odd, then they look like this. X to the power odd. X to 1 kinda is like this when you go for an extreme. When it comes to curving, it's straight. And then x equals to 1. My graph looks like this. That's -1. Y equals to x shifted to the right by it here. Special case. X to 1. The graph looks like this. Y equals to x. X is x to 1. So that would tell us up to a leading coefficient how the polynomial looks like. Now the rest is about vertical reflection or vertical stretching. This factor doesn't know what's around it, and depending on what comes from those terms at x equals -2, the graph can look like that at -2, or it can look like that at -2, right? So the signs of the other terms at -2 will determine that. So all we have to figure out what A is, whether there is a vertical reflection, and what the vertical stretch is. A contains both of those pieces of information. Maybe I'll make a note here. A contains, stores the information of a possible vertical reflection and the vertical stretching. And to figure out what A is, all we need is a point on the graph I have an easy point on the graph, 0, -4. So if x is 0, f of x should be -4. So I put that into my function, that information into the equation. Wherever I see x, I plug in 0 and I simplify. And what do I get? I get -4 equals to a times 2 times 1 times -1. That would be -2. So if I divide both sides by -2, I will get a equals to 2. And that gives me the final form of the function. So the only mistake that's still possible is, I don't think of it as a mistake, but maybe the powers were even, but they were chosen too small. By testing another point, you can figure that out. But go with the simplest choices, linear or quadratic. And for the purposes of our course, that's going to be enough. So that was question 27. Let me see if my answer is consistent with what's on the answer key. And it is. Cool.